Okay, so in this video we want to look at an example for finding some information about the mean and the standard deviation on a sampling distribution. Before we get started, I want to remind you of a couple of things. We already talked in class about the idea that the mean of the sample is going to be this, or the mean of the population is going to be the same as the mean of the sample. So we already looked at an example as to why that's the case, but it's very important that you understand once again that the mean of the population, mu, is going to be equal to the mean of the sample, x bar. The other thing that we know is that as the size of my sample increases, right, as the size of my sample increases, that standard deviation of the sample is going to increase, which is why we get this high peak going on. So the formula that we're interested in that case has to do with the standard deviation of the sample is going to be the standard deviation of the population divided by the square root of the sample size. So in other words, regardless of the distribution of the population, the sampling distribution of x bar that we're looking at is going to have, like I said, the same mean as the population, and the standard deviation is going to be given by this formula. So let's look at an example where we're going to be applying that concept. For this example, we want to compute the probability that in a simple random sample of size n equals 10, so size n equals 10, the results of a sample mean IQ is greater than 110. In other words, if I were to go out and I were to sample, if I were to take a sample of 10 people, then the sample mean that I'm looking at, the average of those 10 samples, their IQ scores, the average of those IQ scores, would be greater than 110. That's technically what we're talking about. We already opened this discussion about sample means and everything the other day by talking about the fact that IQ scores are normally distributed. We have a mean of 100 and a standard deviation of 15, and I want to compute the probability that my standard deviation from my sample mean is going to be greater than 110. So let's record a couple of those things down. I know that the sample size is equal to 10. I know that the mean of the population was 100, and I know that the standard deviation of the population is 15. We are told that this has a normal distribution. If we know we're looking at a normal distribution and we are asking a question about the sample, then that tells us that the mean of the sample is equal to the mean of the population. In other words, the mean I'm going to use in this problem has to be 100. The next thing I need to be able to use in my distribution is the standard deviation of the sample. So the standard deviation of the sample is given by the standard deviation of the population divided by the square root of n. So that is, the standard deviation of the population was 15 divided by the square root of 10. When I plug that into my calculator to 4 decimal places, I end up finding that the standard deviation of the sample is going to be 4.7434. So these are the values that I'm going to use when I think about my normal distribution. So we're going to go over to StatCrunch, and we are going to use the normal calculator. So in StatCrunch, let me make this just a little smaller so that you can see it. So in StatCrunch, I go to Stat, Calculators, Normal Distribution, and we said that the mean we are looking for is the same as the mean of the population. So the mean of my sample is going to be 100. The standard deviation of my sample we calculated out to be as 4.7434. And the question that I was being asked was, what is the probability that I'm going to find a sample mean where, or what is the probability that in my sample of size 10 that mean is greater than 110. So we're going to come down here, change the symbol to greater than 110, and the probability of that occurring is given to you right here. So we would say that we can see here this information on my calculator. So what do I know based on the normal calculator? I know that if we're looking at the results from the calculator, we were told that the mean of the sample is the same as the mean of the population. So IQ scores are normally distributed. So if I were to go out and I were to sample, let's say 1,000 different times, I repeated this sample of size 10, then the mean of each one of those samples would also have to be 100. I know that if my sample was of size 10, the standard deviation of my sample sizes is going to be about 4.74. And the probability, so this is the part that I want you to understand, the probability that my sample mean, remember I'm sampling, let's say, 1,000 different times, the probability that my sample means, that in my sample means that I am going to find a mean with greater than 110, in other words, results of 110 or greater, the probability of that occurring is only at approximately 0.176. 0.0175, if I do that right. So if we were looking at this, that's approximately out of, let's say, 100 samples, out of 100 different samples, I would expect only approximately one, maybe two of those samples to result in a mean IQ score of greater than 110. And you can see that that's the interpretation that I have written down here. So the probability of obtaining a sample mean IQ greater, the probability of obtaining a sample mean IQ greater than 110 from a population whose mean is 100 is approximately 0.02. So in other words, again, if I were to take 100 simple random samples of size 10, the individuals from this population, and if the population mean is 100, then about 2 of those samples are going to result in a mean IQ that is greater than 110. That is what the sample mean tells us, and it allows us to start inferring information about a population.